Hello viewers, welcome to my channel. In today's video, we are going to see about laws of logic and the problems using laws. The laws of logic, that is commutative law. P or Q, that is equivalent to Q or P. Similarly, for AND operator, we have P and Q is equivalent to Q and P. Next law is distributive law. For two operators, AND operator and OR operator, that is P or Q and R is equivalent to P or Q and Q or R. Similarly, we interchange the operator and have a similar formula. Then next law is idempotent law. P or P is equivalent to P and P is equivalent to P. Then next law is associative law for two different operators, OR and AND. P or Q or R, that is equivalent to P or Q or R. Similarly for AND operator. Then identity law. P or 0 is equivalent to P. Similarly, P and 1 is equivalent to P. Then next law is null law. That is P and 0 is equivalent to 0. P or 1 is equivalent to 1. Next law is negation law. P and negation P is equivalent to 0. P or negation P is equivalent to 1. Then next law is absorption law. That is P and P or Q is equivalent to P. P or P and Q is equivalent to P. Next law is De Morgan's law. P or Q is equivalent to negation P and negation Q. Similarly, for AND operator we have. Next law is involution law. Negation of negation P is equivalent to P. These are the different laws of logic. Now, also we have different equivalences. That is modus ponens, that is P to Q is a formula which is true statement and P is a true that implies Q is true. That is, we say P to Q is a premise and P is a premise, then Q is a premise. This is Q is true. This you call it as modus ponens. Similarly, we have modus dolens. And then distinctive addition says that if P is true, then P or Q is true. Similarly, if Q is true, P or Q is true. Then conjunctive simplification we have P and Q implies P, and similarly P and Q implies Q. Similarly, we define distinctive simplification. Then we define chain rule, which are very useful for the for solving the problems. That is P to Q and Q to R. That implies P to R. This is chain rule. Then conditional equivalent, this is also very important while solving the problems. P to Q, that is equivalent to negation P or Q. This equivalence we are often using it in problems. And by conditional equivalence also we have the formula, and contrapositive also we are using it often. That is P to Q is equivalent to negation Q to negation P. These all equivalents can be proved by means of truth table. Now, we are going to solve the problems. Show that P to negation Q is and P to negation R, that is equal to negation of P and Q or R. That is, you know that P to negation Q is of the form conditional equivalence P to Q equivalent to negation P or Q. By using that formula for two terms, we get negation P or negation Q and negation P or negation R. And then now you use De Morgan's law for the both the terms. That is, negation P or negation Q is equivalent to negation of P and Q and negation of P and R. Again, you use De Morgan's law, you get this term, negation of P and Q or P and R. This is equivalent to negation of P and Q or R by means of distributive law, which we want the result to be proven. Next example says that prove that negation of P or negation P and Q and negation P and negation Q are logically equivalent. Uh, how we solve it? First, you take this this term, that is left hand side term, that is negation of P or negation P and Q. This is equivalent to, again now use De Morgan's law, you get this equivalence. Again you use the same De Morgan's law for the second term. Negation of, we get negation of negation P or negation Q. Negation of negation P is nothing but P by involution law. So you get that term as that is equivalent to negation P and P or negation Q. Again, by distributive law, you get negation P and P or negation P and negation Q. Here, negation P and P is, we know that this is equivalent to 0. 0 or anything. 0 or negation P and negation Q is same as negation P and negation Q. Third example says that P and Q biconditional statement with or is equivalent to B, P and negation Q or R and negation P or Q without using truth table. Here, biconditional statement can be written as by means of conditional statement. That is, we know Q by conditional statement with or is same as Q to R and R to Q. Q to R and R to Q. Again, Q to R can be written by means of conditional equivalence as negation Q or R and negation R or Q. Next example says that prove that P to Q is P and Q to P or Q is a tautology without using truth table. Now, again, P and Q to P or Q is nothing but negation of the conditional part. This one is, you call it as a condition. P or Q, you call it as a conclusion. So, negation of the condition or P or Q, that is a condition conclusion. That is equivalent to, by De Morgan's law, negation or negation Q or P or Q. Again, here this all the operators are or operator, so you can remove the bracket and then you, by using commutative law, you get negation P or P or negation Q or Q. So that is negation P or P is 1. 1 or 1 is nothing but 1, which is 1 says that it is a tautology. Next example, prove that P or Q or R is equivalent to P and negation Q to R without using truth table. P to Q or R. Again, as usual, you apply the conditional equivalence negation P or Q or R. Now you interchange the bracket by means of, by using associative law. You write it as negation P or Q or R. That is, again, you use De Morgan's law and then write it as negation of P and negation Q or R. Now it is of the form negation of something or R. So that is equivalent to P, that is this one. Within the bracket, this term is condition. So I write it as P and negation Q to R, which we required. Next one, next example, verify that the proportion P and Q and negation of P or Q is a contradiction without using truth table. Contradiction means we have to prove that this is equal to 0. Tautology means we have to prove that the answer should be 1. Now you take the formula, that is P and Q and negation of P or Q. Now P and Q, again now you use De Morgan's law for this one. So I get negation P and negation Q. Here all the operators are AND operator. So I can remove the brackets. So by removing and then using commutative law, finally you get the answer as 0. Then next example, prove that P or Q are negation of negation P and negation Q or negation R, or negation P and negation Q or negation P and negation R is a tautology without using truth table. Here we have taken this last two terms, that is third term and fourth term, and find an answer. That gives the answer as P or Q and P or R. And then now you take the second term and get an answer. And then you add all the things P or Q and the first, second term and third and fourth term. Finally, you get an answer as 1. Show that, next example, show that P to Q and R to Q is equivalent to P or R to Q without using truth table. Here, P to Q is nothing but negation P or Q, and R to Q is nothing but negation R or Q. Then here you write by distributive law as Q R negation P and negation R. Now, this is by commutative law, you can write it as negation P or negation R or Q. So now you take by negation outside because of De Morgan's law, a negation of P or R or Q. So that is nothing but P or R to Q, which is the required answer. Next example says that show that P to Q and P to R and P to Q and R are equivalent. Now you take this term, that is this proposition, that is P to Q and P to R. Now you write P to Q as negation P or Q and rewrite P to Q, P to R as negation P or Q. And then we get, and you use the distributive law, we get the answer. Next example, prove that negation of negation P and Q and P or Q is equivalent to P. Here you take this left-hand side term and now apply De Morgan's law for this one. So we get negation of negation P is P, P and negation Q, P or negation Q and P or Q. Here P is common and we have two operators. Then we get we can apply distributive law and we get the answer as P or Q and negation Q. Q and negation Q is 0. P or 0 is nothing but P. Thank you. Subscribe my channel.